All right, so we're going to get some more practice in using the Punnett square. So again, we can see the parent's information is already displayed for us. Parent A or parent 1, parent B, parent 2 over here at the bottom or on the side. So I'm going to change colors for us. All right, so here we go. We're going to bring parent 1 down and do the same for this side. Bring it down again. Okay. Now, this is similar to what you would have learned in chemistry about how to write it. So we're going to bring this one across again, bring this little guy across and across again. The capitals, it doesn't matter which order the capital letter gets written in. Down here at the bottom, this is similar to chemistry. Remember, like if we were going to write sodium, had to be capital N, lowercase a. In this case, if there's a dominant and a recessive, it's heterozygous like this, then the dominant needs to be written first, then the recessive should follow. That's just a good tip to make sure that you have it written correctly. So let's get rid of sodium down here. All right, so now let's answer our question. What's the probability of the offspring being homozygous and dominant? Okay, well, I see two boxes again that have two capitals. So that gives me a 50% chance of getting an offspring that's homozygous dominant. And then I see the same probability here, a 50% chance of getting heterozygous. Okay, the homozygous recessive, two lowercase a's. That's not an option at all. That's a 0% chance. So for parent A and parent B here, no matter what they are, this is a flower, this is a dog, this is their only options here. Okay, so we need to talk about what do these options mean. Let's say we have two dominant and a recessive. So we'll practice one more together. And this one you could probably do on your own at this point. Bring the capital down from parent A, bring the lowercase one down, bring that recessive down. Then we're going to move across. Okay, so what's the probability of getting homozygous dominant? 0%, not going to happen. We have a 50% chance of getting heterozygous and a 50% chance of getting homozygous recessive. So same combination here that we just did. I'm going to fill this back out for us to follow along. Okay, so we know 0% chance, 50% chance, 50% chance. That's not always the case. But this information here, these numbers that we get, is called the genotype. We need to write that down. Genotype, the genetic makeup of two alleles, the genetic information. This is what's on the inside. Nobody can see the genotype. We don't know what combination everybody has. We don't know that what your probability was just by looking at you. So the genotype is the genetic information. The phenotype is the physical appearance or the visible traits that we are able to see. So for example, this is my sister and she has brown hair, but I have blonde hair. So that means our parents had to be carrying that recessive allele because there's no way that we would have gotten brown hair and blonde hair. If both my parents were homozygous dominant, then I too would have brown hair. So that means that my sister has to be a heterozygous brown. That means she's carrying that blonde with her, but the trait that's being expressed here is brown. So phenotype is the physical expression, is what you can see. The genotype is just these letter number combinations that will be on the inside. That's going to be really important to know. Genotype, phenotype. So that's where we're going to stop. We're not going to talk about monohybrid cross quite yet. But this is what you're going to be practicing. You're going to be practicing with a Punnett square. You're going to be practicing determining what is a genotype versus a phenotype. So please come back and watch these videos as you need to, and please let your teacher know if you have any questions.